Example number 2, simple inhibited growth. A tank initially holds 200 gallons of brine solution containing 1 pound of salt. At t equals 0, another brine solution containing 1 pound of salt per gallon is poured into the tank at a rate of 4 gallons per minute, while the well-stirred mixture leaves the tank at the same rate. Find the amount of salt in the tank after 10 minutes. So from this problem, we're going to designate y of t to be the amount of salt in pounds after t minutes. We need to know the initial amount, and we also need to find the amount after 10 minutes. So I'm setting up t of 0 is equal to 1 from the information up here, and we want to find out how much salt is in the tank after 10 minutes. But our next step will actually be to set up a differential equation. And that is going to be set up by the rate in minus the rate out. How much salt and mixture is being poured into the tank, subtracting the amount coming out. And here's how we set this up. The rate in is going to be, there's 1 pound per gallon, given from up here, 1 pound of salt per gallon, and it leaves the tank at 4 gallons per minute. So multiplying these two together, we have 4 pounds per minute. That's the rate in. Salt is going into the tank at 4 pounds per minute. The rate out is going to be the amount of pounds divided by 200 gallons, because the entire tank holds 200 gallons, multiplied by the rate that it's escaping. And it says that it's leaving the tank at the same rate of 4 gallons per minute. We don't know how many pounds of salt there are, so we're using our y of t divided by the 200 gallons, and that gives us the rate out is y of t pounds divided by 50 minutes. So taking the information, we set up the differentials and separate the variables. So dy dt is equal to the rate in, 4, minus the rate out, y divided by 50. And using some algebra where I'm a factor out of 1 over 50, we're going to have 1 over 50 is times 200 minus y. And what I did was I factored out a 1 over 50 from this top expression. So now I can use my separation of variables. I divide both sides by 200 minus y to get 1 over 200 minus y times dy. And I cross multiply my dt to get 1 over 50 dt. Now we can set up the integrals both sides. And I have the integral of 1 over 200 minus y dy is going to give me minus the natural log of the absolute value of 200 minus y. And on the right side, the integral of 1 over 50 dt will be t over 50 plus c. Our next step in the process will be to find out c. We want to find the specific constant value for this problem. And since we're given an initial condition that y of 0 is equal to 1, I can make my appropriate substitution. So y is 1, t is 0, and we find out that c is equal to the negative natural log of 199. And I make that substitution right here. So this is our new equation. Minus the natural log of the absolute value of 200 minus y is equal to t over 50 minus the natural log of 199. Now we're going to divide both sides by negative 1 to get an equation where it's all positive, or positive on this side. And I do that so we can solve for y. Solving for y, I'm going to use the fact that e and natural logs are inverse functions and make each side the exponent of e. So on the left side I have e raised to this expression here, and on the right side I also have this expression as an exponent of e. And since e and natural log are inverse functions, we have 200 minus y on the left side. Now on the right side I just want to talk about what happens going from this step to this step. Since we're adding our exponents, one of our rules of logarithms is that, or exponents I should say, one of our rule of exponents is that when you're adding exponents, that comes from multiplying terms with the same basis. So I could rewrite this as e raised to the negative t over 50 times e raised to the natural log of 199. and e raised to the natural log of 199 is 199. So you'll see on this step right here, I have 200 minus y is equal to 199 times e to the negative t over 50. The final step will be to solve for y by subtracting 200 from both sides and then multiplying through by -1 to get this equation here. We're almost done. Now that we have our equation in terms of y, we can find the value of y when t is equal to 10 by replacing t with 10 here, and that gives us y at 10 minutes is equal to 37.073 pounds.